today, how the supply chain is being built. So yesterday or the last class when we were discussing about the supply chain or greenfield analytics, what we did, we put, so if you see there is retail distributor slash customer, right? So actually we are not looking into individual customers, we are looking into our retailers or distributors, right? Then their forwarding agents actually here. We have a country distribution center. Sometimes what might happen, you'll have multiple distribution center. Let's say Apple iPhones, right? Uh, recently, though they are building that manufacturing plant and manufacturing started in Pune. Earlier, our country did not have a Apple iPhone manufacturing plant, but there will be country distribution center. So what will happen? Maybe from China, Thailand, or Philippines, wherever existing Apple manufacturing plant is there. So they will have, let's say, continent-wise regional distribution center. From there, products will flow to country distribution center to the forwarding agents, then from the forwarding agents to the retailers or distributors or customers, right? So in our supply chain, we're looking into customers, not individual customers, but aggregated customer demand through retailers or distributors. Then obviously manufacturing plant, right? Then manufacturing plant will send their order to the supplier of raw material. So if we look into the complexity right now, we are just looking into the stage 2 of the complexity. Why it is stage 2? Because we are just looking into the retailer, though we did not input in between, we did not put any forwarding agents. We are just looking into retailers or distributors and our distribution center, right? I can just add and make it 2.5 saying that there are a global distribution center and country-wise distribution center, right? We did not do that. What we did for the exercise, class exercise, what I had given, I told you there are 4 customer demand major distributors across 4 from metros. Now, if I have to put a distribution center, where should I put that? And I have told you from each distributor or the retailer how much weekly demand it is coming, right? Total around 245 per that number of electric scooters or vehicles weekly basis from different centers, different distributors or retailers. Then based on that, you have, most of you found out what is the distribution center, where we should put the distribution center. So this is, if you see, there are only 2 participants, 2 stakeholders, the retailers or distributors. Then I have a distribution center. I can make it little bit more complex, saying that, okay, I need to put a manufacturing plant or a factory, right? So that option is there also available in the supply chain simulation, what we are doing. Then once I put my manufacturing center, then I have to go back and see that where are my suppliers, right? Because to manufacture a product, I need raw material, I need components, right? So that is where supplier will come into picture. So when I put all those 4 stakeholders, starting with retailer or distributor, then distribution center, manufacturer, then the supplier. So that will be the 4-stage supply chain, which finally will be able to end up building and simulating, right? But we started very small with the easiest part. We put some distributors across 4 metros. Then we trying to find out which will be our distribution center, right? So this is something known as multi-echelon supply chain, because there are different stages, multi-stage supply chain, right? Considers all levels, all inventory within an organization. So there are single echelon supply chain and multi-echelon supply chain. Single echelon supply chain is when there are different suppliers, manufacturers, distribution center, forwarding agents, customers. But at each stage, the decision for purchase or decision for transportation, everything happens individually at that distribution center, at that customer location. So it is not integrated. So, and it used to happen. It used to happen a lot 3 years or 40 years back, because that time we did not have a ERP system. We did not have this much internet connectivity where we can send the order. So everything was manual. So rather than sending manually, so let's say I need to purchase something, I'll go to the local distributor. Local distributor will send a tender, right? So everything was like kind of a decision. Everything was made at a local basis. So whenever we think of single echelon means each distribution center, each factory, each stakeholder chain, supply chain used to take decision individually, right? Obviously looking into the best interest for that distribution center. But when we talk about multi-echelon, which we saw in the previous slide, so we have 4 stages and we are taking a decision integrated. I'm just not looking into which is the distribution center, because if you see, you are getting a Aurangabad, close to Aurangabad, you'll find that distribution center. that is actually nearer to Mumbai and very far from Kolkata, some distance from your Chennai and some distance from Delhi, right? So if the distributor, let's say whoever is Delhi or Kolkata or Chennai, right? They want to take, and I have to keep the best interest for those individual distributors. Ideally, I should put my distribution center nearby them, right? And that will be a single echelon decision because I'm looking into individuals' best interest. But when I'm looking into the whole supply chain's best interest, can I maximize profit or reduce cost from the overall supply chain? Then that is something at a this decision being taken at a network level, right? So that is where inventory planning, inventory targeting, serviceable objective, right? Are you able to meet all customer demand at right time, right product, right place, right? Everything, every decision being taken at a global or coordinated or integrated level, right? So that is what going forward or whatever we have discussed so far, we are just looking into a multi-echelon system where everything is integrated. So we assume that all the information they have implemented ERP system, everybody is in line with the objective that they have to maximize the profit or reduce cost for the overall supply chain, right? Any question, any doubt on the last class what you did in the greenfield analysis? I'm not sure why my camera is not good. Yeah. So the question was basically I had asked what is the distance, maximum distance from the distribution center. I did not ask about the location. Few of you asked written about the location. So the question was about kind of what is the maximum distance. I think maximum distance was close to 1390 or 1400 kilometers, and minimum distance will be from Aurangabad to Mumbai to 77 or 300 kilometers, right? Some of you, some groups have mentioned the location name. And second part, I'm not sure which period you have taken, but if I'm doing that analysis, I'm getting where is my question? So I'm getting the total flow cost is around 2 lakh, no, 24 lakhs 83 336. I'm not sure why that much difference is coming. I think only one or two group are close to that number. Otherwise, other groups have got a bigger number. So why I'm repeating this, because the next all the analysis, whether it is a simulation, network optimization or transport optimization, we'll be using the same data. Only thing that will keep adding the complexity. So just make sure that when you are taking the data, right? I guess one of the problem might have been because I have taken, I have told period from April to June. I'm taking the complete month of June. So in case some of you have taken this end date as June, 1st of June, that might be little bit different than what my answers are getting. And also look into the demand, because for one or two group I looked into that number, it is a very big number because demand was very like kind of uh, so I'm not sure how you have taken the demand I had mentioned from each. So the D means Delhi, Mumbai, M means Mumbai, K means Kolkata, and C means Chennai. So there are 16 demand, right? So from Delhi customer for E30 product. So Delhi customer means this is Delhi your distributor or retailer, right? So parameter is order interval, because I have told you order 7 days weekly order. Then quantity requirement is 2 for E30. For E60 it was 50, right? So I hope I have not done any mistake, but these were the number. I hope 250, 15, 10, 7. So these were the numbers which I had given in the Word document, right? So just check that whether you have taken that number correctly, right? Because the answer, yes, obviously all of you must have got the site location as I got around 19.845. Some of you have got 20.03. That's okay, because like I said, sometimes when we select the location where I am putting clicking, where you are clicking, for me Delhi might be here, for you little bit far or here and there, right? So that's why I have got this answer. Aurangabad, I think it is close to, yes. So, but what has happened? Product flows, if I look into total sum, because I've taken only one distribution center, I'm getting around 24 lakhs 83,336. Some of you have got 16 lakhs around something, but others I'm not sure. Any doubt, any questions while running this experiment?
Yes, sir. So can you just show me like again the flow cost estimation part once again? So I got around 16 something and my location was correct. Like what you got, it was nearby that only.
Yeah, just check that if these numbers product flows are something like this, because if these are not matching,
Yes, sir.
just check randomly few numbers if this is not matching. So whether you got this from GFA DC, so this is basically Aurangabad to
Yes, sir.
Delhi E30 product, whether flow pieces is 26.
Yes, sir. No, sir. So this is a bit different. It's not exactly the same.
Then the data, how you have like taken this demand, have you put correct numbers here?
Yes, sir. Correct numbers. Like order interval 7 and the numbers which you have given in the assignment.
And this first occurrence is first day.
First day. Yes, sir.
Okay. Do one thing, share your screen. Let me check what has happened. Just a minute.
Okay, sir. Wait a second. So, how to open the like the last one? Yes, sir. Yes, sir. Yes, sir. Sharing, sorry.
Yeah.
Yes, sir. Can you see my screen?
Yes.
Yes, sir. Sir. Yes, sir. So this is what I'm getting.
So number of pieces it is showing more. So
Yes.
so just go to the data again. Click on the data. So
Yes, sir.
go to periods. End date you just put 30th 30 because I have taken June complete month. April, May,
Okay,
June.
sir.
So 6:30. Not, but 6 will remain same. 6 then
Yes,
30.
sir.
Yeah. Now just click on
And
data.
then, okay, sir.
Then click on GFA experiment. Just run it again.
Okay, sir. So this is coming like this.
Yeah. So now just click on this from. Click on this from.
Yes, sir.
Drag it to the little bit top. Click and drag it to the top. Yeah, there. So yeah, just put it there.
Okay. Okay.
Yeah, it is almost close. So 24 lakhs 45,816. So I got 24 lakhs 43. So almost very close, right?
So almost same. Okay,
Yeah.
sir.
So I think that period was because I have taken full month. I told April to June. So that means April month
Yes, sir.
full, May month, and June.
Okay, sir. Thank you, sir.
Yeah. So others, if you have taken different months or different numbers, because in some cases I saw a huge difference in numbers. So that might be the problem. Just make sure that you are making it correct, because other answers going forward also will vary a lot if you are taking something else, right? So before I proceed, just let me quickly discuss a few of the things, what actually we are trying to do today. So last class, if you remember, we discussed on the GFA scenario parameters. What we did basically, we added customers, their locations. So there are three ways to add customers. So if I do not have idea about where my customers are coming from, right? I can take a population density. Let's say I'm starting a new startup. I know that this is a FMCG product and people will buy it. If my marketing plan works well, there will be demand from customers, right? So I can take on population density, but most of the cases, right, we'll know that where are our distributors, retailers. So in those cases where we have an idea where our major demand will come from, distributors or major retailers, so we can select the location in the map. If you see, like you have selected those locations, you can select those locations. Then third point, like I showed, if let's say there are 100 distributors or 200 distributors, manually adding that or clicking that in the kind of uh, that map will be very difficult. So I had told you how to like download that data, export that data Excel file. There you can include all the details, then import it again, right? But in our case, because there are only 4 locations, so we are going to trying to exercise on that, right? So I asked you to just click it. So in the other case, if you download the Excel file, there you have to put the latitude and longitude data, right? So that will be little better, kind of in terms of providing correct information or calculating correct results, right? Then we define the products. In your case, there are 4 electric vehicle models, E30, 60, 90, 120 that you have defined. Defining customer demand. So you have to go to the demand table, demand type, periodic and historic. Periodic means like what you have done here, right? Weekly, you have told there will be order of 2, 5, 10 like that from for different customers, for different retailers, what kind of electric vehicle demand is there. Let's say you do not have idea about that. You have not done any forecasting exercise, right? But you know that for the last 1 year, what has been the historical demand, right? So in that case, you will choose historic, and for the last every month or every week, whatever has been the demand, you will populate that, and accordingly the software itself will forecast the number for you, right? You need not worry about, because the number what I've given you, that is on future. So somebody has created a forecast for it, right? Let's say you have not done that, right? In that case, you can use historic data also, right? Order interval and quantity. So both interval and quantity can take different distributions. In our case, what we have done it fixed, that every week there will be order of some quantity, fixed quantity, right? So that means from April to June, let's say from Delhi, E30 vehicle, that E30 electric vehicle model, every week there is a order of 2, right? Every week there is a order of 2 number of electric vehicles E30. But that might not be true, right? Those numbers might vary also, those order quantity also might vary, and then the order like days, right? The difference, sometimes order will come in 3 days, sometimes order will come after 16 days, right? Those things also can vary, right? So just think about how supply chain will become more complex, right? So I can add those distributions also, how my order numbers will vary and how my order dates will vary. But in our case, we kept it very simple, saying that every week there will be a fixed quantity order, right? Then I had shown you how to import data from Microsoft Excel workbook, right? I can just the file which I'm working on, I can export it, update the location data, different demand data, then import it again and work on that. Creating groups, this is something I have not shown, I'll show you today, right? This helps little bit when it gets more complex. Rather than looking into individual stakeholders, we can group them and try to kind of simulate them. So this part, creating a new experiment, you did that. You created a single warehouse or distribution center. Then define minimal number of warehouses and their location subject to maximum service distance. So same case, if you run it, say that, okay, rather than only one distribution center, I think one group has done that. So they have run with both one distribution center and 2 distribution center. So in that case, what will happen? You will get 2 distribution center for 4 customers, serving 4 customers, right? So this is a very simple exercise, and at the end I had asked you what kind of information we have not required, right? Because if you see, we have not taken many things. So we started with a very simple example. we have not talked about the transportation cost, what kind of vehicles, what will the vehicle kind of type, vehicle kind of cost, right, associated with the transportation, right? So the and those kind of things we need to add and look into the simulation part, right? So this step we have already done. You have also, most of you have done the exercise. In case of any doubt, please let me know, because unless you are clear in this, we cannot proceed further. So this is the first step in our supply chain analytics, where we have done a greenfield analysis. So now what we'll do, we'll try to simulate it, right? So this simulation again will come back and do the risk analysis on that. But today we'll just start with a simple simulation. But before going forward, so what kind of different parameters will be available when you are running a simulation, right? So there is something called replacement policy, frequency, and economic order quantity, EOQ. We have not discussed that. I hope all of you know what is the economic order quantity. Next class I will talk about this through different examples. Then transportation mode, whether it is a sea transport, air transport, if it is a air transport, or sorry, or road transport, if it is a road transport, what kind of vehicles. Then transportation cost, right? Transportation cost can be fixed, transportation cost can be variable, right? So depending upon how much distance it is covering, if the transporter can say that for each delivery I'll take 2000 rupees, or they might say that for each kilometer I'll charge 10 rupees or 15 rupees, right? Then safety stock in the warehouses, in your customer side, customer again, retailer or distributor, how much safety stock will store, right? Lead time and dwell time, right? So how much time it takes for a transporter to deliver the products at customer end, distributor end, right? How much time they have to wait. So that will be the dwell time. So and dwelling time can be at both the end. So when they are going to unload the material, they have to wait for few hours or for half a day. When they are like loading the material, loading the components or loading the products at, let's say, warehouse or the manufacturing plant, there also they have to wait. So this is something waiting time. Then those things also can be deterministic or stochastic. Stochastic means probabilistic, right? So there is no fixed time. Sometimes it will be very like within 2 hours loading happened and you went on. Sometimes you have to wait for one day. Truck strike happened and transport like road is closed. You have to wait for one day. So in that case, it is a variable, probabilistic, right? Stochastic means probabilistic. Then demand, annual demand at markets. If you see, we are just putting some numbers, like I showed you from Delhi distributor for vehicle E30. Every week there is a demand of two, but in reality that might not be true, right? It every week or every 10 days, 15 days, 3 days, there will be different demand. And whenever a customer comes and requests for those kind of vehicles, so the distributor or retailer will aggregate weekly basis and send that order, right? Then processing capacity. So this production we have not discussed because we have not added that complexity of factory, which we'll try to add. Then fixed cost, that production or assembly line with that manufacturing cost, whether it is fixed or variable, right? So that kind of complexity also can be added. Then throughput. Think about ITC, think about HUL or any companies, right? So how much maximum? So not that each plant can produce lakhs of 50,000 products in a day, right? So there will be a throughput, minimum capacity, maximum capacity, right? Why minimum? Because the plant, like those people who are work in plant, they are coming in shift. You cannot just say that, okay, I do not have a demand, you do not come to shift. So every day they will come and they have to work. Maximum, obviously, depending upon how much resources you have a maximum capacity, maximum throughput, right? Then storage capacity, right? So not all everything is fast moving that you kind of produced or manufactured and next day or within 1 week you have transported it. Think about electronics, think about big manufacturing loads, those products which are used in industries. They will be staying it in the plant for 6 months, 3 months, 8 months, right? So what will be the inventory cost for that, right? So if you see, these are the main things whenever you talk about supply chain and somebody asks about how you design a supply chain or what kind of things you will consider in a supply chain. These are your answers. Again, it is not the overall, this is not a complete answer. Depending upon situation, the answers might be more complex, and we'll see that when we run those simulations. You'll see there are around 60 or 70 parameters. If you go to USA, or Europe, there is something called the transportation itself. There is something called CO2 emission. Every plant, every manufacturing plant, warehouse, every quarter and every 6 months, they have to show that how much carbon dioxide emissions are happening, how much green house emissions are happening. So there is a cost, there is a penalty associated with it. So whenever they are running the supply chain simulation, they have to add that. But obviously in India, we do not have those kind of penalty, those kind of charges as of now. So we are not including that. So again, depending upon location, depending upon kind of country, depending upon what kind of products, think about the same thing. If I look into the, let's say fruit or milk, there is something concept of perishability that I have to consider in my supply chain simulation, because products are there. If not after 3 days or 5 days, they will get spoiled, right? So, but these are the minimum things you have to take care of. Then, depending upon the product, healthcare, COVID, vaccines came, so that requires a separate storage. So that you have to take care, and you have to consider that how much products will be wasted, because due to transportation, sometimes these packages fall and break, and the vaccines gets wasted. So how much percentage of products, and then that is not maybe the case for a compressor or maybe automobile. So if you like thousands of vehicles getting transported, maybe 5 or 10 or 20 vehicles get kind of damaged. But in case of vaccines, 10%, 20% vaccines, if you see the data during transportation itself, they get wasted, right? So the point is, when like anytime somebody asks you, in case some of you got into this kind of role, depending upon the industry, you have to add certain additional parameter. And any questions, any doubt on this? But this is the at least minimum things you have to think of when somebody asks about how you design a supply chain for them, or what are the things you have to take care of when you talk about supply chain. Any questions, any doubt on this? So today we'll try to again exercise. I'll show you the same thing. The same thing you have to repeat in your class exercise. I'll upload after maybe another 20-30 minutes. So what things we have not considered? Multiple distribution center. That one thing I think one group has considered. Then variable processing and fixed warehousing cost, right? In the warehouse what we are keeping, right? So there also you have to have resources, right? So there will be two different costs. One is outbound processing, one is inbound processing. So think about as a warehouse. So remember the image what we saw in the first slide, multi-echelon supply chain, right? So there are suppliers, supplier will send their raw material to the manufacturer, manufacturer will build the product, they'll send it to the distribution center. From distribution center, it is going to the retailer or distributor. So in the distribution center or the warehouses, whenever material is coming to them, right? So that is the inbound processing cost. So from the factory, when material comes to the distribution center, so this is inbound material to the warehouse, right? Same thing when I talk about factory. Factory, what will be inbound? The raw components which are coming from the supplier, right? So that will be processing cost for the factory, right? So depending upon what you are analyzing, what will be the inbound cost will be different, right? So in our warehouse cost, the material when it comes from the manufacturing plant, that is the inbound processing cost. Then from the distribution center, when it goes to the customer, right? So that is the outbound processing cost. So material is going outbound. Outbound is going outside of the your distribution center. Then inventory control policy. So today I'm not going to discuss that, but I'll show you some like minimum things, and we'll discuss that in, because I have not discussed on the inventory control, reorder point, and economic order quantity. Again, I'm not going to discuss that in detail because that has been covered earlier in supply chain or production and operation management. But I'll just cover the basic points, right? So that we are able to do a justice to the simulation. Then transportation distance and cost, right? So that part we did not consider in our previous case in the simple greenfield analysis. Then routes and shipment parameters, right? So distance matrices to use straight distances or real routes, right? So as you are using academic version, right, we do not have the option for a real route, right? Because we are not looking into roads, we are not looking into where rivers or mountains are. We just have the idea that okay, these are the locations: Aurangabad, Mumbai, Delhi, Kolkata, right? But if you see that we do not have a clarity on what route to take, what kind of road it will take, right? So that is again that is the limitation of the academic person, but because we are not paying for the commercial license, right? So, but if some of you like in case you work in this kind of environment, you will have the option to work on a real route, right? Transportation options. So if you see full truckload, right? When you are transporting from warehouses to the customer or from the plant to the warehouses, whether it will be a full truckload, right, or a less than load, less than truckload, right? LTA. Then sourcing policy, right? Again, sourcing policy related to how you source products from the warehouses or plant or kind of your suppliers, right? So these are the few things we need to take care for our simulation. Then by running simulation, what we are analyzing, like you did analyze in the previous case, in the greenfield analysis, what did you analyze? The distance from each of the customer to the distribution center. Then I asked you what is the maximum distance, minimum distance. Then you analyze the flow matrix, right? So flow matrix is how it was calculated. Number of pieces, number of requirement, number of demand from the customers multiplied by the average distance, right? So altogether for the 16 demands, you aggregated and you found that answer, right? But when you are running simulation later on, today basically we'll do a very simple thing. But there are many things we can actually analyze. Finances, how much revenue, how much expenses, distances covered by vehicles, products, orders, right? Whether we are able to meet all the orders from all the distributors. Sometimes there will be back order, sometimes there will be a less like kind of partial order fulfillment. Then there are different ratios. I'll show you few of them. Then time, how much time in value added activities, how much time in non-value added activities, how much vehicle utilization ratio, right? But majorly we look into these kind of things, KPI or statistics. What is the total transportation cost, fixed warehousing cost, total profit, total revenue, and there is something called ELT service level. Can any, okay, I have already written that here. ELT is expected lead time, right? So just imagine as a customer or a distributor or retailer, right? So what they want, whenever they are putting the order, the manufacturer or the company should send the material or the product immediately as possible. So that is that something expected lead time. So whenever they are putting order, so they are expecting within 7 days or 3 days, they'll receive the order from the company, right? So whether the company is able to, obviously that is not only expectation that has been agreed upon. Think about Maruti, right? We go to the Maruti dealer or distributor, we book a car. So weekly basis, that distributor will be sending the requirement to the Maruti plant or warehouse. Okay, we have three these kind of model requirement of this model three, that other model five, another model six, right? So 6, 5, 11, 3, 14. There is a order of 14 to the Maruti plant or warehouse. So from Maruti warehouse, so there has been a service level agreement between the Maruti company and the distributor that whenever order comes, depending upon the production scenario or production status, maximum days it will take 15 days. Within 15 days, you will get your order. Again, it might vary model to model, right? If a model is there which is new, the like kind of expected lead time may be 3 weeks, 4 weeks, or sometimes in if you look into Royal Enfield, sometimes there is a waiting time of 3 months, right? So that is what agreed upon between the distributor, who is our customer, and the company, right? Then customer revenue, on time delivered, how many times the product or the like whatever was order was delivered on time, delayed orders, lead time anyhow we have discussed, right? So this is what we are going to cover today, at least simulation. Then later on, so there are two more important things left out: network optimization, transport optimization. Then later on, we'll come back and do the risk analysis. So your project most probably will be on the risk analysis. I'll show you how to carry out scenario and risk analysis, and it will be based on that. So right now, let me just quickly go through the simulation part. Where is that? So let me do with the other what we are doing last class. Yes. Yeah, I think this. Okay, so I think this was the one where kind of I was doing the last class. Let me just quickly go through the data. So what I told, same thing. The exercise what I've done, the detail remains same for your that electric vehicles. We have to add few more data points, right? Where is this? So I had 5 customers. Okay, so 5 customers in Odisha, Raulkela, Sambalpur, Bhubaneswar, Barampur, Baripada. Then there were demand. Not this one. Okay, I can do with this one also. So for, let's say I'm doing this for the Odisha customers, and you can do the same thing for the overall India customers, right? So I have here again similar type of EB 20 electric vehicle, 20 electric vehicle, 40, 60, 80, 20, 40, 60, 80, right? So there are 5 customers and there are different demands are there. There are 5 locations. Period is uh, okay. So I hope all of you remember what is demand coefficient. Demand coefficient takes care of seasonal demand variation, right? Then products, I have these 4 products, CP 20, 40, 60, 80, right? So this is, if you remember, this is exactly same as your the exercise what you have done, right? So I have 5 customers, 5 into 4, so 4 products, 5 into 4 means 20 demand, different type of demand. Okay. So what will I do? So I'll click on the data. So GFA Scenario already they have run it, but let me run it again. Okay. So total flow distance will be how much? So there are 4 distribution centers. So let me just run with one only. So there are around 2,756 pieces being ordered overall in that 3 months. 2,756 vehicles. Total flow cost is 4,17,363, right? Because we have not added any cost as such, right? So for you also, whatever result you have got for the like kind of that exercise what I have given, right? So now what we'll do, we'll right click on that result, right? Remember the steps, the right click on the result. So if you see, I can convert that into a separate greenfield analysis scenario or a network optimization scenario, simulation scenario, or a transport optimization scenario, right? So today we are starting with simulation. Later I can do network optimization, transport optimization, right? So just click here, convert to SIM scenario. So class work 24th version, GFA. I'll rename it. Okay. Simulation one. So now what we are going to do additionally is we are going to add some additional parameters, right? What will be the additional parameter? We'll add some transportation. So click on the all, go to the vehicle type, right? Uh, Name, let's say truck one. So I'll just take the same whatever I am going to give you in the exercise, same numbers I'm going to give. So parallelly also you can do it for the whatever the data I have given you, right? So you can use that same data. so that later on you need not have to put much. Let me just share that exercise here also. Just a moment, I'm just sharing the data with you so that we can run the simulation parallel. So after some time, I'll same data I'll upload in the Google Classroom also. But before that, I'm just sharing that with you. Okay. So you can download that and work on that. So right now, what will put truck one capacity 20 vehicles. It can carry 20 vehicles. Let me share my screen. So know that what we did. So whatever GFA result you have got, right click that and convert that into a simulation scenario, right? Now click on this. So once you open this page, that will be in the basic, right? Click on the all, come to vehicle type, name the vehicle, right? Then capacity you have to mention. So that means in one run, what is the full capacity of the truck? How many vehicles it can carry? Again, you can like actually define it for different products, but again, we are keeping it a little bit simple, saying that okay, it can carry total of 20 products, right? Then speed. What is the average speed of that vehicle, right? I have written as 50 kilometer per hour. Unit conversions, tariff. So if you see that how many different kind of parameters are there overall, right? Suppliers we have not added. Later on, once we add factory, we have to add suppliers also. Now the sourcing part, right? So this part is important. Let us try to understand what is this, right? Uh, what is a delivery destination? If you see, there is something called GFA DC group, right? Let us try to understand what is that. So for that, we have to go here in the groups. Okay. So we did not create anything, right? It has already been created. What is this GFA DC group? If I just click here, right? So it is showing that customers, right? All the customers, Raulkela, Sambalpur, Bhubaneswar, Brahmapur, Baripada, right? It has created a group called GFA DC group. I can rename it and say that customer group also, right? So all the customers, it has been one group has been created. I can create if I go to another group. So because anyhow I do not have multiple distribution center. So let me remove that later on. I'll create. There is something called product group also. Where is this? So I can create a product group also, right? I'll go here and add product group products. EP20, EP40, EP60, EP80. Right. So why we are doing this? Sometimes let's say all the parameters rather than adding for individual customers or individual products, if say everything is same for all those four customers or four distribution centers, we can add the parameter for product group rather than individual customers. I'll show that. So what I have done so far, only vehicle types I have added truck, capacity unit was given, and speed was already given. I did not do anything. Then sourcing policy, right? So if you see delivery destination is customer group, right? Then what for different type of product, EB60, EB80, 20, 40, right? Then from where it is coming, GFA DC, right? Actually, we can change the location. So this is, I think, close to. Okay, let it be GFA DC. Raj, I don't know where it will go. Yeah. So what I was talking about the sourcing, right? So let us try to understand what does sourcing mean. So what is my delivery destination? So I have, rather than selecting individual customers, I've selected different customer group. Why different customer group? Because I have different products also, right? EB60 is being delivered to different 4 or 5 customers, right? EB80 similarly to different customers, EB20 and EB40, right? So now what is your sourcing policy, right? So this is important. So let us try to understand it. So what we are trying to say is that whenever delivery is happening, on which logic it will happen, right? Whenever from your warehouse or from distribution center, the material is going to. So if you see sources is your GFA DC, in our case, I think it is close to Rourkela or something, right? When it is going to the, or in your case, it was Aurangabad, right? Do the same exercise, because that is nothing but your class exercise 3. If by the time we complete this exercise you were done with your class exercise, you need not have to spend more time on that. You just can upload your answer there, right? So I have already shared the information, right? So if you look into, there are different kind of logic or different kind of algorithm on which you, from your distribution center, this sourcing will happen. So fixed source, right? If I says that, okay, for a particular location, for a particular customer, always your material or the components or the products will come from a fixed distribution center. That is one way. Or I can make it dynamic. So depending upon wherever it is, whether cheapest, closest, fastest, or wherever it is most inventory, your distributions. But in our case, what happens? We have only one distribution center. In the network optimization, when we make more distribution center, I'll show you that how it changes. So sometimes what will happen, if I check that, okay, cheapest source, right? Whichever is the transportation cost is cheap, from that distribution center material will come. Or whichever is the fastest, whichever is nearest, but it takes less time but more costly, right? So sometimes if I push the fastest, so the location might be, or the distribution center which will be chosen might be the fastest one, right? Or I can say that, okay, I have multiple sources for the single, let's say, distribution or Delhi customer. The material will come from Aurangabad also, material will come from, let's say, Saibabad or Ghaziabad also, right? So I can split that also, how much order will come from different distribution centers. Whenever I select this uniform split or split by ratio, if I select this, I have to say that, okay, what are the parameters? So because I have a GFA DC only one side, ratio is 1. That means 100%. If I had more sites or more distribution centers, I have to, let's say, 50-50% split. So I'll say that, okay, from Aurangabad 50%, from Ghaziabad 50%, right? But in our case, it is only kind of one distribution center. So I'll keep it very simple, fast and fixed source, right? So any questions or any doubt on this? I hope you are following the same thing in your data, what you have already done. Okay. So once you have defined sourcing, next is actually we should define product flows first, path first. So what you have to define, I have already mentioned in the Word document which I have shared, right? So if you go to that Word document, so you have to shipping, right? Then sourcing, if you come from the down one, right? What is the path, right? So we have already defined sourcing, that is first fixed source, then shipping will define, right? Where it is. Sourcing, then shipping. Okay. So shipping, how we are going to define? Our source is GFADC, destinations is customer group, right? Products, all products. I have created a product group, right? Then vehicle type truck one. So what I'm saying, how it is shipping being considered, from GFADC source to the destination customer group, different products, right? Vehicle type is truck one. So here, if you see the type of delivery can be different types. Less than truckload, that is LTL, less than load, then full truckload, FTL, FTL with periodic check every week or every month, how you define that check will happen, and accordingly you can change that also. Then pending orders, wherever there is more pending orders, fast delivery will be happen to there. Then push schedule means in a particular date, no matter whether order has come from the customer or not, order will go to the, so that is a push model, right? So you are pushing your product. Obviously it cannot happen in automobile, so there won't be any storage place, but it might happen in FMCG product. Whether people are buying or not, you are putting your products in the store, right? So push can be again schedule. Depending upon different schedule, you can put or mention the quantity, or push can be uniform also, right? Uniform quantity you can put. Then prohibited, some cases you have to say that okay, from this place, from this location, from this distribution center, it will not go to the, let's say sometimes there is a state border, so let's say when this states gets split, or there are sometimes there is a conflict between different states, right? So there will be a like prohibition that okay, from this state, if you see for some products you buy, you will say that okay, these are only applicable to be bought in these areas, these locations. If those kind of prohibitions are there, you can put those conditions here also, right? But in our case, we are keeping it all open, less than truckload. That means even if the truck is not full, if the demand is there, truck will go and deliver it. If I put it full truckload, unless there is a because what is my full truckload? The capacity is 20. If demand is not there 20, it will wait. It will wait till demand has aggregated to 20. Then only the delivery will happen, right? That time what will happen? My customer service level might get decreased, right? Then priority. If you see this is FIFO, anybody knows what is FIFO?
Sir, first in, first out.
Yeah. So whichever order comes first from the whichever customer location, first delivery will be made to there, right? Or it can be expected lead time, wherever expected lead time of a customer is very high, right? Sorry, very priority, high priority, right? Or the big order first, whichever as the, let's say there are 4 customers, somebody ordered 2 quantity, somebody ordered 20 quantity, somebody ordered 10, somebody ordered 5. So whichever customer ordered 20 quantity, truck will move to that customer first, right? So in our case, we are just keeping it as first in, first out. Then sometimes what happens, and same thing we'll see in the production plant also, right? It is not necessary that the transportation will happen 24 hours. So if the start time, the end time. So what we are saying, all days of the week, 24 hours, my warehouse will remain open. Anytime transporters, the shipper comes, they can load the material, load the vehicles and go. But to be honest, that is not true, right? Sometimes we work only an 8-hour shift or 16-hour shift or 12-hour shift. So that means today, if the transportation does not come, the order will get delayed for tomorrow, right? Sometimes it is only for the 6 days of the week. Sunday might be a holiday, right? So as and like as you like, you can make it more complex also, which will complex means it is actually representing the reality, right? No, like very few warehouses work 24 hours, 24 hours, 7 days a week, right? So those things also you can change, but I'm not making any changes here as of now, right? So as of now, what we have done, we have changes shipping, then sourcing. Next is path, right? So path is very important. So as of now, if you see in the last greenfield analysis, we had not defined what is the transportation cost, right? So path is where we can define what is the transportation cost. So transportation cost from where to where? From our distribution center to the customers, right? So rather than all locations, we'll put customer cost. So if you see rather than customer group, I can say for Baripada, there is a different. So just look into, in your case, it might be more accurate also. From Aurangabad, the transporters, the transporter, what they are charging for Mumbai location might be different for Delhi location, might be different for Chennai location, might be different for Kolkata location, right? So in that case, for each individual customer location, you can put a different equation for transportation cost. But because I am doing it inside Odisha, so what I have done, I have cost calculation. I'll show you. So what is a cost calculation? On what basis your transportation cost will be calculated, right? So product based, depending upon different product, you will say that okay, for E30 this is the transportation cost, E60 this is the transportation cost. For product and distance based, right? Depending upon the distance covered, depending upon the which is actually true. Most of the transporter, even for the packing and movers, whom if you want to transport something from your home to other place, they generally charge based on the distance, right? How much product, how much quantity, and how much distance. Then fixed delivery. On delivery like 200 kilometers, this amount they are going to charge. Distance based with cost per stop, this will discuss when we discuss the transportation optimization, right? How it is different from the product and distance based. So distance based with cost per stop, where it is telling the same truck or the same trailer will go to the multiple customers. So just imagine the scenario. Let's say I have an order of 2 or 5 from Delhi and 10 from Kolkata and 5 from Chennai. So in the transportation optimization, we'll try to see that whether I'll send three different trucks to 3 different locations. I'll send a one single truck, which will first go to Delhi, deliver 5, then go to Kolkata, deliver 10, then go to Chennai, deliver remaining 5, right? So that is what transportation optimization will kind of help us to do. Same thing with the cost per drop, distance based with fixed cost, rate matrix where I can charge that, okay, per different kilometer range, 0 to 100, this is the rate, 100 to 200, this is the range, right? So those are the things. Amount quantity matrix, and that again I have to actually upload it and in my Excel file. Here actually I'm not able to do. What I'm going to do is product and distance based. Sorry. Not product and distance based. I'll just put distance based. Distance based with fixed cost, right? So what I'm saying, what is this variable cost? Variable cost is for kilometer of distance, right? So how much I have given you the number. Fixed is 10,000 rupees. So what happens every time a truck is going from distribution center to the customer, it will charge 1,000 rupees fixed, and variable cost is 10 rupees per kilometer, right? So this is what I was talking about, fixed variable CO2 emissions, right? In some countries, for every transportation you do, right? For the every like kind of vehicle transportation, inbound, outbound transportation, you have to calculate how much carbon pollution you are doing, and based on that, so there is certain not penalty, because that again there is something called carbon credit you have to buy, right? So but in our case we are not doing that. So I hope everybody understand what is a variable cost, fixed cost. Fixed cost is, that's for the customer when it delivers, minimum this is 1,000 rupees per distance basis, variable cost is 10 rupees per kilometer, right? CO2 calculation I'm not doing anything. So distance unit is kilometer. Transportation time, again in our case, transportation time we have kept it same, 24 hours. There is no kind of restrictions in that. Time unit is day. So here if you see, we have to keep it straight, because see, we do not have any road option which is available in the commercial case. Here we just have to keep it straight. So that means whenever, let's say, you are thinking of, let's say, from this distribution center to, let's say, which is this Baripada, no matter whether it is a river or whether the road is there, it is just calculating the straight line distance, which is not actually true. Ideally what will happen, it will go through the road which is available. So the road will be always will be, because straight line is the kind of closest or the shortest distance between 2 points. So the linear or sorry non-linear or the curvature will be much more distance than the straight line distance, right? But unfortunately we do not have that option. We have to go only by the straight line distance. So that is, like I said, that is some limitations in this academic license. Okay, so as of now what we have done so far, shipping we have defined, sourcing we have defined, path we have defined, vehicle type we have defined, then stocking we have to, so we have to go. So what vehicle types done, suppliers not required, sourcing is done, sites, states, not shipping, shipping I have already discussed, sale batch right now not required, product. Okay, so this is what we have to, this is very important, selling price and cost, right? So at what price you are selling it to the distributor, and at what price, this is basically if it is assembly cost, what is the total assembly cost at your warehouse, right? So how much I have given you. So for E30, 60, 90, 120, you can put your numbers 20,000, 15,000. So for me, there are different models, right? 30,000, but I'll take the same number. Forty thousand. So if you see production batch right now, we have not discussed because we have not included a factory. Production also not required right now, which will later add in the next two, after one or two classes. Product groups I have added. Processing time also in the facility we have not. That is something very important, right? It is not that the truck comes and the processing happens, right? It will take time. There is a waiting time, right? That I have not added so far. Processing cost. So this is something again I have to add. So this is the GFA DC. What is the processing cost? So only outbound shipment, products, product group, unit is pieces. Cost is 50 rupees for each product. Let's say packaging and all those things, 50 rupees, right? So I have not put any inbound cost because I do not have a factory. So I have only warehouse. From warehouse, products are outbound to the customers, right? If there was a factory, what I would have done, I would have added from factory to your the kind of whatever to the distribution center. There will be certain inbound cost, right? And periods is 4th April, sorry, 1st of April to 30th of June. Period groups not apart. Payment terms again from sellers to buyers, whether there is any down payment, time period, deferment period. So those things also you can add. Path I have already defined. What is the cost calculation? That is fixed cost 1,000 and variable cost 10. Ordering rules, that is again will come once we add in the network optimization. Locations 46, yeah, 5 customers. Location groups not required. Loading, unloading gates. So see how complex you can make. So like each factory, there will be different gates. Which gate at what time it will open, at what time it will close. So processing time at different gates, those things also you can add. But we'll never get into that much complexity. Inventory. Okay. So this is important. Okay. So this part next class will discuss on the inventory policy. Okay. So if you see there are different inventory policy in your warehouses, in your factory, right? So min max policy means there will be a range of product, right? Inventory minimum this much inventory, maximum this much inventory. Min max with safety stock, reorder point, and how much quantity, unlimited inventory, order on demand, regular policy with safety stock, cross stock policy, X stock policy, right? So there are different policies of inventory which we'll discuss later on. Right now, what I'm putting is no replacement because see, we do not have a factory, right? We have only warehouses defined and we have our customers, right? In your case also, what you have done, you have only one warehouse at Aurangabad and there are 4 customers. So there is no option of replacement because if inventory gets over, that's it because I do not have a factory, right? So in our case, I have kept it very simple. So next class or not next class, after 1 or 2 classes, when we start doing network optimization, we'll add factory. Then we'll have some replacement because once amount of the quantity gets over from your warehouses, so it needs to get replaced. Otherwise, how it will send to? Because warehouse is not a manufacturing plant. It need to get product from somewhere. So it has to send order to the factory. Okay, I have only 100 inventory left, send me another 5,000 units because customer demand each week are coming. So factory will send 5,000 or 500 or whatever the order is, right? But in our case, if you see there is no factory, right? So that's why I will keep it no replacement. Once we add factory, right? I'll show you what kind of other policy, inventory policy type is there, right? So in this case, what I've told you, keep it a large quantity so that it should not happen that. So I have told you to keep 5,000 quantity each, right? Just a moment, I have a call. Yeah, sorry for that. So initial stock, I have kept it a large quantity so that it's not happen that you do not have order to meet to the customer, right? So any questions, any doubt up to this point? So inventory part is done. Then what else is left? Processing cost, then facility expenses we require. So this is the like let's say electricity, all those costs will be applicable, right? So facilities, GFA, other cost, carrying cost, facility cost. I'll add a facility cost, very small amount, 300 rupees. For Christmas, right? So events actually will be helpful when you do a risk analysis. Events is basically let's say COVID happened, or some of the kind of let's say warehouses or some of the factories need to be closed, right? So this is something which we'll do towards the end of our kind of analytics class. So this is something which we discuss on the risk analysis, right? The demand is done. This is factories, customers. I think that's it. Those are the few things. Let me check that the data is okay. Then make sure that your product statistics unit is pieces because those are the vehicles. Okay. So if you see it is running the simulation in the right end, it is running. You can make it faster also. Speed. Each day it is running how much demand, everything. Closing at 30th. Okay, I have not added item. I have to skip that also. So like I said, in the simulation, we have to first include what we are going to see, right? So right click here, just again showing it. So I have run the simulation, but it is showing blank here, right? Because I have not shown that, or I have not told the software what actually I want to see, right? Right click it, click add item, and I have told you what actually I want to see, right? I want to see the total revenue, which will be under finances. So click on revenue, profit, what else? Revenue for cost also, total cost. Uh, then what else is there? Cost of ELT level vehicle uses. Vehicles, average number of vehicle used, ratio to the products, like capacity utilized. So if you see in my case, actually I'm making a loss because if you see my facility cost was too much, 300 rupees per, I think per vehicle. Let me change that. What is facility? Actually, this should be okay. I think my transportation cost is very high. Because in your case, it is from Delhi to Aurangabad, fixed cost is 1000 is much. In my case, I think everything will be lying under 1000 kilometers, right? So that is where in the path I have to change. So I'll make it fixed cost as 200, let's say. But you keep it same because for you it is a larger distance. Simulation experiment, run it. Total cost actually. I think this processing cost was taking as number of pieces. Per piece 300 rupees was too much. So if you see like out of the simulation, what in details I have given, my profit is around how much? 98 lakhs, sorry, 9 lakhs, how much it is? 98 lakhs, 42,863. I have a revenue of around 1 crore, right? 1 crore, 12 lakhs, 70,000. Cost of around 9 lakhs, 14,000. Sorry, 91 lakhs, 42,700. So no, how much is this? 9 crores. What is my revenue? Right, 10 crores. 10 crores, 12 lakhs, 70,000. This is 9 crores, 14 lakhs, 71,000. Then my profit is around 98 lakhs, 42,800. That is basically 10.1 crore, 9.14 crore is cost. Profit is around 98 lakhs. ELT service level is 1. That means whatever customer has demanded within expected lead time, right? I'm able to meet that. Average number of vehicles on an average 0.2, 25%. Vehicle capacity utilization. So whatever vehicles I have utilized, each time vehicles has been utilized around 80% of the capacity, because I have told less than truck load, right? On an average, 80% of vehicle capacity utilization has happened. So you have to do the same exercise for the data I have given, right? Put those numbers and try to find how much revenue, how much profit, total cost, vehicle capacity utilization, ELT service level, and average number of vehicles utilized, right? So once again repeating how to do. So that is one thing I had not told in the class exercise. Right click it, add item, and you'll be able to select from finances, ratios, vehicles, right? So whatever you want to see, click there and put OK, right? And that information you'll be able to see in the dashboard. Right? And any last questions? Okay. So if not, I'll stop here for today. Chalo, take care.